Welcome to today's lesson. Today we're going to continue factorising expressions. Much like last lesson, we're going to start off by drawing our grid method and placing the two terms in the question into the answer boxes of the grid method. We start off by checking if there's a number that we can factorise out from these two terms. The highest common factor of 5 and 7 is just 1, so we cannot factorise a number out. Now we look to factorise out a variable. Both terms contain a, so we can factorise a out. However, both terms have a power of a. Because we have a power of a, we would like to factorise out a power of a also. This term has a squared and this term has a cubed. We will factorise out the lowest power of a. So we can factorise out a squared. That's because we can divide this term by a squared and this term by a squared, but we would be unable to factorise out a cubed from this term if we decided to factorise a cubed. Once I've figured out what term is going to go on the left side of our grid method, now we just need to divide. 5a squared divided by a squared, our 5 will remain on the top row. A squared divided by a squared is going to cancel out, so we're left with just 5. 7a cubed divided by a squared, again the plus 7 will just remain. But now we're doing a cubed divided by a squared. A reminder that when we're dividing variables with powers, we subtract the powers. So we're doing 3 take away 2, which is 1. So it's going to be a to the power of 1, which is just a. Now that we've factorised, it's important that we write in the final answer. So a squared on the outside of the bracket and 5 plus 7a on the inside of the bracket. On to question 2. We draw out our grid method, having 4a cubed plus 10a to the power of 5 within the answer boxes. And we start off by seeing which number we can factorise out of 4 and 10. The highest common factor of 4 and 10 is 2. So 2 will go on the left side of our grid. We now look at the variables. Because the variables are the same, they are both a, we're going to factorise out the smallest power of a. A cubed is smaller than a to the power of 5, so a cubed will be factorised out as well. Now we need to do 4a cubed divided by 2a cubed and 10a to the power of 5 divided by 2a cubed. To start off dividing, we'll divide the numbers first. So 4 divided by 2 is 2. And a cubed divided by a cubed will cancel each other out, so we're left with just 2. Next, positive 10 divided by 2 is positive 5. And a to the power of 5 divided by a to the power of 3. To do that, we need to subtract the powers, so we will end up with a squared. So our final answer, 2a cubed, and then in brackets 2 plus 5a squared. On to question 3. And we place 5cd plus 3cd into the grid method. Again, we start off by checking if there is a number we can factorise out of the two terms. But again, the highest common factor of 5 and 3 is just 1. So we're not going to factorise out a number for this question. Next, we check what variables we can factorise out. Both terms have a variable of c, so we can factorise c out. But also, both terms have a variable of d, so we can factorise d out. So therefore we'll have CD on the left side of the grid method. Now we do the division. 5 will just remain on the top row. C divided by C will cancel out, and D divided by D will cancel out, so we're left with just 5. We can check that that's correct because 5 times CD is 5CD. On to the next box. Positive 3 will remain on the top row, and CD divided by CD, again the variables cancel each other out completely, so we're left with just plus 3. So for this question, the answer will be CD on the outside of the brackets and 5 plus 3 on the inside of the brackets. Question 4, and we're putting 15AB plus 12BA into our grid method. Again, we first need to check if there's any numbers that can divide 15 and 12, and the highest common factor of those numbers here is 3, so we can put a 3 on the left side of our grid method. I'm now checking for variables that I can divide both terms by. Both terms have a variable of A, so A can be written on the left, and both terms have a variable of B, so B can be written on the left. It doesn't matter that this term is AB and this term has BA. These could be rewritten so that they look the same, so we can factorise out AB from both terms. Now onto the division. 15 divided by 3 gives me 5, and AB divided by AB will cancel completely, so we're left with 5. Positive 12 divided by 3 is positive 4, and BA divided by AB will cancel out. Again, the A's cancel and the B's cancel. It doesn't matter that this is written the other way round. So the final answer for this question, 3AB, and then in brackets 5 plus 4. Question 5. We have ABC as the first term and positive ABD as the second term. We cannot factorise any numbers out for this question because we don't have any numbers in the two terms in the question. So we go straight to checking for variables that appear in both terms. Both terms have a variable of A, so that can be written on the left, and both terms have a variable of B, so that can also be written on the left. C and D will not be written on the left because they don't appear in both terms. Now we go on to the division. ABC divided by AB, the A's will cancel out and the B's will cancel out, leaving us with just a C to write on the top row. And likewise for positive ABD divided by AB, first we'll have a positive term, the A's will cancel and the B's will cancel, leaving us with just D. And then we need to write the final answer, AB on the left side, followed by C plus D on the right side inside the brackets. And on to question 6, which is the final question for today. Again, we draw out our grid method. And we have A squared B in the first box and positive B squared A in the next box. Again, we cannot factorise out a number because we do not have a number in front of the terms in this question. So we start looking at the variables. First we look at the variable A. We have A squared in this term and A in this term. Because we have powers with our variables, we need to select the lowest power of A to factorise out. This A has a power of 1, and that is lower than A to the power of 2, so we're going to factorise out just an A. After we've checked A, we now need to check B and see if we can factorise out any B's. Here we have B, and here we have B squared. The lowest power of B is B to the power of 1, so we're going to factorise out B also. Once we've dealt with our left-hand side, we now need to divide. We will take this variable by variable, so A squared divided by A is A, and B divided by B will cancel each other out, so we're left with just A. On to the next term. Positive B squared divided by B will be positive B, and A divided by A will cancel each other out, leaving us with just positive B. So overall, our answer for this question is AB, and then in brackets, A plus B. And that concludes today's lesson on factorising.